Okay, started. So since this is 4 pages, I will probably do the problems which I think are important, and then show some stuff in between, rather than do everything.
Is it a 2-page test or is it a full page?
I had a 4-page test.
You said it's
Okay.
so it's
For you guys, it was 50 points, or is that what he said?
Yeah.
Okay.
so the most important.
I had a 4-page, but I will still do the most important ones. On Blackboard, I posted a 4-page because that's what he gave me. Okay. So the first problem I am not going to do, but I'll write down the formula that you guys need to know for that one. So you're given R vector. You need to know that the tangential is the derivative of the magnitude of the velocity vector. You need to know that. Then the problem asks you to find the acceleration vector. You do that using the velocity vector. And then the normal vector is equal to the square root of the absolute value of the acceleration vector minus the tangential vector. So just know these formulas, essentially. I will do number 2 because the graph, the circle graph is important for that one. We are given the vector negative sine of ti plus cosine of tj. Okay. The first part is finding the r vector at pi over 2. That's easy because you just plug in pi over 2 and you get negative I. The second part is finding the r vector at 0 and you get j. Part C is the velocity. So you find the velocity vector, which is taking the derivative, and you get negative cosine of t I minus sine of t j. The velocity vector at pi over 2 is negative j. So all of this is easy, but I want to show you guys the graph. The acceleration at t is the derivative of velocity, so it's sine of ti minus cosine of tj, and at pi over 2, it's just I. So this should be in the answers I posted. So is anyone copying these down? Okay. I was going to draw the graph on that board at the top, so you guys can copy it. Any questions so far, though? No. So for the graph of that one, though, they draw the circle. Sketch and label R, so R of 0. For that, we got just J. We start at the origin, and we just draw a vector going up. And we label it. Okay? The next part asks us to draw the vector of velocity at pi over 2, starting at the tip of r of pi over 2. For r of pi over 2, we got negative I. For that, we started at negative 1i. Since the radius of the circle is equal to 1, the negative 1 would be on the x-axis. So this is the tip of r of pi over 2. Did that make sense to everyone? Essentially. So the velocity vector of pi over 2 is negative j, so it's going down. It's a negative j direction, or negative y, and we label it velocity of pi over 2. The next part is the acceleration of pi over 2, and we got that as a positive I, so it's going in the direction of positive x, and it starts at the tip of pi over 2 of radius. So we draw it like that, and label it. Any questions on this? Like, unless you've seen it before, it might be weird. Do you guys want me to do number 3? It's the derivative with respect to time of the radius.
All right. I know the velocity, the velocity and acceleration formulas are given to us, but will the r and the r dot and r double dot be given to us?
You'll be given like whatever you need. It may not be exactly like this. For this one, you need d theta over dt,
Okay.
so they gave it to you.
Okay.
But I don't know. There may be different versions of problems. You might be given r with respect, or some other theta function with respect to time, like theta is equal to 2t or something. So d theta dt is equal to 2. Does that make sense?
Mhm.
I'll write it down. So for this one, we are given cosine, r is equal to cosine of theta over 2, and we are told d theta dt is equal to 2t. Okay. So then if we are to find r prime, it is doing the chain rule. Since r is in terms of theta, we can get dr over d theta, but we need to multiply it by d theta dt, because it's asking the derivative of r with respect to time. That's what the dot always means. Okay? So you have your parts. So they might not give you d theta dt. They might give you just theta is equal to, say, 2t. So then for this example, d theta would be equal to just 2. And then you'd make that substitution regarding whatever you're doing. So any questions on this problem? I'll do the next part too. Just so r dot was equal to negative t sine of theta over 2. So when you're doing the derivative of this, what rule do you need to do? The product rule. Because it's a combination of negative t and sine of theta over 2. Most people just forget that, and that's why they get the question wrong. So for r double dot, that will be equal to taking out the negative sign, t times cosine of theta over 2 times the derivative of the inside, which would be 1/2 d theta dt. That's the taking the derivative of the sine of theta over 2. So then we'd add to that, the derivative of t is just 1, sine of theta over 2 times 1, because the derivative of t is just 1. Did that make sense? So we did the product rule here.
Can you go back to the last one?
Yeah.
Where did T come from? Right there?
This t,
Yeah.
that's when you were doing the derivative of this. This is the answer. So if you do it, d theta dt is 2t. So you get t, and then the derivative of this is 1/2 cosine of theta over 2. Okay. Number 4 is going from velocity to r. The thing you have to remember is you need to find your constants. When you do an integral, you still have C1. So do you guys want me to go through the work for that? Or
Everything is important.
You just look it up there. You just integrate each.
oh yeah, I'll do it for a part of it. And if we have time, we'll go back. So we're given the velocity of t is equal to cosine of t of pi t over 2 I plus
Drop the T off the cosine.
1 over t. What?
I think you put T on the cosine, it's not.
Oh yeah, cosine of that. So 1 over t j plus e to the minus t k. So we'll just do the I component. The integral, so r vector is equal to the integral of velocity with respect to time, dt. So what is the integral of cosine of pi t over 2? The integral of this. 2 over pi, or I'll write it out. for you.
Oh, you have to like make
Yeah, you have to.
the
So it's the integral of cosine of pi t over 2, right? If this is our u, our du is equal to pi over 2 dt, right? So we need to multiply the inside by pi over 2 and the outside by 2 over pi. So then this is equal to 2 over pi sine of pi t over 2 plus c1. You can't forget the c1. The way you figured that out is because they tell us r of 1 is equal to 0 as a vector. So this means that it's 0i, 0j, 0k. So r, so now this is just the I component. R of 1 is equal to 2 over pi times sine of pi over 2 plus t is equal to 1 plus c1. Okay? What's sine of pi over 2? So this is 1. And all of this is equal to 0. Okay? If you solve that out, c1 is equal to negative 2 over pi. So then our I component for the vector r would be 2 over pi times sine of pi over 2t plus c1, which is minus 2 over pi. So this would just be the I component. Okay? And then you do that for j and e. I'll go through it. So that's our I component. Our j component is 1 over t. So what is the integral of 1 over t? Yeah, the natural log of t plus c2. Okay. So then we have, when t is equal to 1, natural log of 1 is what? 0. So r of 1 is equal to 0 plus c2 equal to 0. So c2 is equal to 0. Okay? The integral of the k component, e to the minus t dt, is equal to what? Negative e to the minus t. You bring it, whatever the coefficient in front of the t down, plus c3. R of 1 is equal to negative e to the negative 1 power plus c3 equal to 0. So this is negative 1 over e equal to positive c3. So c3 is equal to plus 1 over e. Okay? So if we were to write down the entire function, r of t is equal to, we can take out a 2 pi for the I component. 2 pi times sine 2t minus 1 I plus the natural log of the absolute value of t, j, because we found c2 to be 0, plus positive, but we have a negative. It was a negative part here, so minus 1 over e to t, the exponent t. That makes sense? Plus 1 over e, because that's our c component. Okay.
Do you include the C's with the components, or you just add them at the end?
Like I included the c's with I, with a j and a k.
Okay.
You include that.
Can you explain how you included the C1 with the I? Like, because it's a negative 2. Oh, you wrote it all together.
Yeah.
Sure. Okay, that makes sense.
Like are you saying like I took out the 2 pi out?
Yeah, I didn't know you had put the 2 pi in originally. Like, you would have to add it back into the minus C.
Yeah, you have to. Come on now. Any questions on this problem? Don't get tripped up with the integration. Are you guys good with this? I won't be doing the satellite problem because that's just plugging in the formula. If we have time, we'll look at it. There's one thing though that you guys learned in class. It was, okay, this is the sun and the earth is going around it. Okay. Our A value would be the center to the outer as a major axis. So the formula would be 2a, the total distance to the longest distance, which is like apogee or something. We'll call that capital A, plus the diameter of the sun, plus the smallest distance to the outer end, and that was like perigee or something. You guys learned this in class. Know this formula because they might ask you to find the length of the major axis or the diameter of the sun or something like that.
I figured that I
But this formula make sense? I mean, it's pretty simple. It's the apogee or whatever it's called, is the distance to the outer end, the farthest one. So, for 6, get of it. No, you guys can figure that out. Okay, for 7, let's go with 7. We are given a function of x, y, and z. It's the negative of the square root of z minus x squared minus y squared. Okay, so we have to find the domain. What would the domain of this be? The domain is all the possible values that you can have for like x, y, and z. Okay? So in this case, our z minus x squared minus y squared have to be greater than or equal to 0. These added are in the negative, it'd be, which is not real. So the restrictions on the domain is that our x, y, and z, this function has to be greater than or equal to 0. Not the entire function, but that section. The range is all the values that the function can be. And what would it be in this case? Yep. Less than or equal to 0 because we have a negative sign. So if there was no negative sign, it'd be all positive or equal to 0. Now the open and closed stuff, I sort of explained it wrong on the SI session on Friday, but I wrote a description of it on the answer sheet. So, is this region open or closed? It is closed, and they ask you why.
Because the boundaries included.
Yep, because it includes it includes the boundary in the shape. Is this region bound or unbound?
Is it bound?
It's unbound because it's not all of it is encompassed. Like there's a portion of it which doesn't have a boundary.
What shape is that?
So it does ask you to sketch it. So let me sketch it for you. Because you do need to sketch it in order to see all of this stuff. What do you guys think it looks like?
It's a conic section.
A little bit.
It starts off at a point because if x and y are 0 at the origin, z is equal to 0. And as we increase x and y, the parabola in 3D shape increases. Like you can try plugging, so when you have a problem that asks you to sketch it, you can try plugging in values to try to see what the shape might look like. Yeah.
Wouldn't it be downward?
No. Because
is greater than or equal to
Hold
x
on.
squared plus y squared.
The range is less than zero.
Because, okay, the function itself is like a fourth dimension. Okay? This graph is in terms of x, y, and z. Okay? So you're just trying to graph x, y, and z. So if you look at the x, y, and z portion of it, z is not directly, but z is equal to x squared plus y squared. Okay?
Why is the vertex not a equal?
It. What was it? Am I missing something? Oh, because you're actually supposed to graph when it passes the point. You're supposed to graph when it passes this point. So the function of 1, 1, 3 is equal to negative square root of 3 minus 1 squared minus 1 squared, which is equal to negative 1. Okay. So negative the square root of z minus x squared minus y squared is equal to negative 1. Therefore, z minus x squared minus y squared is equal to a 1. Therefore, z is equal to x squared plus y squared plus 1. Yeah, that's what I was. But when you graph it, it's only in terms of x, y, and z. So you were supposed to graph it after you did the point. But otherwise, yeah, I could start at the origin. Did this make sense, how we got the equation? X squared plus y squared plus 1 equals to z. Because we need the point. We plugged in the point in the function. The function would be equal to a negative 1 at that point. Then we got it in terms of x, y, and z.
I'm still confused on that whole like close and unbounded thing. Can you explain that to me?
Okay, yeah. So this negative 1 is like a fourth dimension. Because the function, which stays constant. Maybe you guys followed me on that. Let me open up. So there's essentially four possibilities if you include everything. We have closed. That is if it includes a boundary. So a function could be like that, or it could be an ellipse, or something like that, but it includes the boundary. Okay? We have open when it doesn't include the boundary. Okay? Did that part make sense? That's how you know. So if it's closed, you'll have an equal sign. Or in this case, we had a greater than or less than sign when we found the restrictions. Something like that. Okay? When it's bound, that's if it's a disk or has a fixed radius. So it could either be an ellipse or a circle. Those are I think the only two possibilities that you need to know. Okay? It's titled bound because on all sides it's closed. Okay? And then there is unbound. That means that one of its sides will never have and edge. It'll go on into infinity. So in a parabola, all of this will go on into infinity. Okay? Now you can have bound and open. That means there will be no equal sign. So you'll have dashed lines on the outside. It doesn't have an outer rim because I don't want to use the word boundary. But it's still called bound because it's a closed shape. Yeah. Did that make sense? Like these are essentially the 4 different ways. And then you can mess around with those 2 combining with that. So you can have unbound and open where it doesn't include the edge of the parabola. Did that make sense? Okay. And then, did you guys follow how we got this equation? Yeah? Since we got that equation, z is equal to x squared plus y squared plus 1. You graph it, and that's part of the points. Okay. Any more questions on this? And then, there's actually another shape I want to show you guys with boundaries. Say we have the function of x and y equal to 1 over the square root, we'll say 16 minus x squared minus y squared. Okay. What will its domain be?
16 minus x squared minus y squared equals 0. No.
Or we can say x squared plus y squared. We'll make it a minus 9y squared. And I'll show you guys why. Okay? That's a 9. So x squared plus 9 has to be less than 16. Because if these numbers are greater than 16, you'll have a negative square root. Okay? So the range will be what? The most the square root can ever be is what? 4. Because these could be the lowest values, or the square root of 16 would be 4, right? The most we can ever have inside the square root is 16. So then the greatest the function f can be is 1/4. Sorry, I said that backwards. That's the lowest the function can be because as we decrease the denominator, f increases, right? So when it's equal to 1/4, it can be, so we can write this as 1/4 less than or equal to f. Or we can also say 1/4 less than or equal to f. Did that make sense? The greatest the denominator can be is a 4, right? So the function f can equal 1/4. Now, if we increase x and y, we are increasing the denominator, which is decreasing under the square root, which is increasing the function. You guys follow that?
How is it increasing the function?
Because as we increase the denominator,
It goes to 0 now.
sorry, as we decrease the denominator, the function increases, right?
Yeah.
So whenever we increase x and y, we're subtracting more and more from 16.
Okay, got
So as we're increasing x and y, we're decreasing the denominator, which increases the function. The maximum the denominator can be is 1/4, so that's the lowest the function can be. And as the denominator decreases, the function increases. Did that all make sense? Okay. Now to find the equation for the boundary. Sketching the region of the building. So we had x squared plus 9y squared less than 16. Okay? To find the equation, because that was our domain, right? In order to graph it, we sort of always try to get this number to be a 1. Okay? And these to be, what do you call denominators? So, actually, I'm going to make this a 9, just to go easy on us. Or we'll make this a 16. Okay? Just to make it easier for us. So then if we are trying to make this a 1, so then we get x over 4 quantity squared plus y squared less than 1. Did that make sense? So if we're to graph this, what would it look like? Yeah. So the longer length would be, so it's a horizontal ellipse. Yeah. Okay. So then this is what it would look like. You wouldn't include the edge because it's less than, not equal to. Okay. Also, we had a less than sign here because if this was equal to 16, it'd be a 0 in the denominator, right? We can't have that, so it was just a less than. I forgot to mention that, but do you guys understand that? We had a less than sign here because if it was equal to 16, it'd be a 0 in the denominator, which is not possible. In the problem that we did before, it could equal 0. So this one is. So we have a less than sign here. That means we don't have an edge on this one. So is this bounded?
Yes.
Sorry, yeah. So it's bounded, yes. Is this open or closed? Now do you guys get bounded in? Yeah? Okay. And we also, I forgot to show this, but it includes all the values less than, right? So you need to shade it in. If you don't shade it in, it's wrong.
What is bounded? You need to shade it as well?
Yeah.
Okay.
Because it does include all of the values, since it's less than.
If it was greater than 1, would you have to shade it?
If it's greater than 1, you need to shade everything on the outside. But then, would it be bounded? No. It wouldn't be. Okay. If you had the likelihood of this happening are almost impossible. But if the outside was shaded, I would say that it is not bounded.
But it's closed.
I don't know if it's closed or open.
It closed because it includes the boundary.
Is that the boundary there? It has no boundary.
I don't know, that's just like it's unit bounded, it's an option on
There wasn't either option?
it, and both.
Oh, okay. And then I remember a homework problem that tried to find the domain mathematically. Like it was, if I looked in the examples, and I remember something from last year doing that. Make sure you look at that homework problem. Because sometimes you can't do it by inspection. Hopefully I cleared up some stuff. For number 8, that's the limit problem. I will not be going over that unless we can do it at the end, because those are normally easy. Number 9, though.
Watch out.
9 is a good problem because it all makes sense logically. You just need to follow the steps. So y is equal to 1/4 x to the 4th power. The point is 1 comma 1/4. So what is y prime? X cubed. Y prime of 1. Y double prime. 3x squared. And y double prime of 1. 3. Okay. They will give you this, but I recommend that you guys memorize this because they probably will not give it to you always. So it's the magnitude of y double prime divided by the quantity of 1 plus y prime squared to the 3/2 power. Okay. Y double prime at 1 is 3. So it's at point P. So we have a 3 on top, divided by 1 plus 1 squared to the 3/2 power. So it's 3. This is 2 on the inside, divided by 2 square root of 2. Part B, the slope tangential is y prime always of 1, which is equal to 1. The normal slope is the reciprocal of the tangential slope since it's perpendicular to it. So we have a -1 as that. What is the formula for the normal vector? Plus or minus I plus mnj over the square root of 1 plus mn squared. Yep. That you do need to memorize. Unless I gave it to you. Did I give it to you? Yeah? No? Then you do need to know.
That's a really useful piece of information.
So in this case, we have plus or minus I minus j divided by the square root of 1 plus -1 squared. So you guys can't see it, but so it's plus or minus I minus j quantity divided by square root of 2. Now, how do we know if it's a plus or minus? Yep, so let's graph it. So if you draw a circle at the point they want us to look at, we have the center. From the point towards the center. Is that a negative I or a negative positive? So it's negative. So then our answer here would be a negative normal vector. It's actually the unit inner normal, not the normal vector. Just the unit vector of it. So what's the difference between a unit vector and a normal vector?
Units have direction, right?
Units have directionality. That's why we needed the negative sign, because it's the negative direction. It doesn't have a magnitude. You guys have this copied? Okay. So what is the radius of this circle?
1/k.
Radius is 1/k. So in this case, it will be 2 square root of 2 over 3. Okay. I shouldn't have deleted this. Where is it? Okay. To find the equation of the oscillating circle, a center point and our origin is 0, 0, right? So in that circle right there, we can write a vector equation. That'll be to go from the vector O to C. We can go to O to P plus PC as a vector. So this is one vector plus that vector. That gives us the vector OC. Okay. The vector PC is, so we found the unit inner normal vector, right? That is just the direction of PC. So we want the vector PC. What we need to do is we need to multiply by a magnitude. So rho is our magnitude times the normal vector, which is just the direction, gives us an actual vector. So we will have 2 square root of 2 over 3 times negative I plus j divided by square root of 2. That time I distributed the I. The square root of 2's go away. So vector PC is equal to negative 2/3 I plus 2/3 j. Okay, did that make sense? Because that's very important that you guys understand the logic behind it. So vector OC is equal to OC is equal to the vector OP. How do we get the vector OP? We have all the points from P and O. So it's the final minus initial. So we'll have 1 minus 0 plus 1/4 minus 0. Did that make sense? Because origin is 0, 0, and we have the point. Plus the vector PC, which is negative 2/3 I plus 2/3 j. If we add them, we get 1/3 I plus 1/4 plus 2/3 is 11/12 j. Okay. The center point, we always label it H, comma K for the 2 points. So the vector O to C is equal to H minus 0 for the origin 0, I plus K minus 0, J. Did that make sense? It's the point minus 0, K minus 0. Therefore, we have H equal to 1/3 and K equal to 11/12. The equation of a circle, all right, is x minus h quantity squared plus y minus k quantity squared equal to rho squared. So in this case, we'll have x minus 1/3 quantity squared, y minus 11/12 quantity squared equal to rho is 2√2/3. If we square that, we get 8/9. So this would be our equation for the circle. Did this all make sense? It's very logical in this way, but so you will definitely have like a problem like that. Any questions on that? The next problem is just, it's not hard, it's just taking the derivative or stuff like that over and over again, or doing a matrix. So do you guys want me to go over that? You can either do that one or number 11. Both are the same idea.
For that first one, letter L, I believe it is.
Yeah.
Is the x referring to the position vector?
Yeah, x of pi, you go to the original radius,
Okay.
and then the I component is your x component. Your y component is the j, and z is k.
Okay.
So do you guys want me to go over that problem? 10? No? What about 11? Okay. Let's do 11. Did this problem make sense that we just did? We're given the r vector of t equal to ti plus t squared j plus t cubed k. So the velocity vector is what? I plus 2tj
plus 3t squared k.
3t squared k. The magnitude of the velocity vector is the square root of 1 squared plus 2t quantity squared plus 3t squared quantity squared. So we have the square root of 1 plus 4t squared plus 9t to the fourth. So some of these problems you won't have pretty answers, like that'll simplify and stuff. So if you do get something that doesn't simplify like that, just keep going with it. Make sure you did your math right, but
Divide equal to 1 over 2 to the fourth out.
it would, I mean, this is fine.
Oh,
Like sometimes you could have where it was like t plus 1 quantity squared and square root of that. I think that was in 10 or something. Like this, you could simplify the t plus 1 absolute value, and then if t is greater than 0, it's positive or something. So sometimes things will simplify, sometimes they won't. The acceleration is the derivative of that. So what did you guys get?
0I plus 2j plus 16k.
Yep. And then jerk was 0I plus 0j plus 6k. You can just write the k part. You don't need to write the zeros though. Part E was the cross product. And then since they didn't show the magnitude signs, you don't do the magnitude. They want you to do that separately. So we have I, J, K, 1. So the velocity was 1, 2, t, and 3t squared. Acceleration was 0, 2, and 6t. Make sure you guys all sign the sign-in sheet, wherever that is going. Who hasn't signed? So this is equal to I times the component 2t times 6t. So you go across, so we have 12t squared minus 3 times 2, 6t squared. Then you subtract the j component. Then you do 1 times 6. So it's 6t minus 0 times 3t squared minus 0 plus k, which is 1 times 2 minus 0 times 2t. So it's 2 minus 0. So in this case, we end up with 6t squared I plus or minus 6tj plus 2k. Does that make sense? You guys all remember how to do matrices? The magnitude of the cross product is the absolute value. This can be rewritten as 2 times 3t squared I minus 3tj plus 1k. So then if we do the magnitude of 2 times the square root of 3t squared quantity squared plus negative 3t quantity squared plus 1 squared, we get 2 times the square root of 9t squared, or 9t to the 4th, plus 9t squared, plus 1. Does that make sense? I'll let you guys talk. So this problem isn't hard, you just have to go through and do the formulas. So you guys sure this is 50 points for you guys?
It said 2 pages, but I heard 2 pages.
Don't tell me never makes a mistake.
I can check the revised schedule just to make sure.
I don't think it says anything, which is weird. I don't know.
I'll look, but I trust you.
If it is 2 pages, I think the problem that will be on there is number 10, and then like the oscillating circle and the domain and range.
I don't know why it would be.
I'll write that.
points, all this content, you just
Yeah.
have to work in.
We had 4 pages. But... Okay, moving on. The formula for K is the magnitude. Make sure you signed in. Make sure. The magnitude of V cross A divided by the actual value of V cubed. So then we have 2 times the square root of 9t to the 4th plus 9t squared plus 1 divided by the magnitude of velocity 9t to the 4th plus 4t squared plus 1 to the 3 halves. M is equal to the matrix x dot, y dot, z dot, yada yada yada. So then
Did they give you these equations?
for this problem they will.
Okay.
These are the same way like I, j, and k, except you do have a value for I essentially. So this is equal to 1 times 12 minus 0 minus 2t times 0 minus 0 plus 3t squared times 0 minus 0 equal to 12.
So you treat the top 2 or the top 3 as your I, J's, and K's?
Yeah.
Okay.
And it's the same otherwise. Tau is equal to m over the magnitude of v cross a quantity squared. So then we have 12 divided by 4 times 9t to the 4th plus 9t squared plus 1, which is equal to 3 over 9t to the 4th plus 9t squared plus 1. and they'll give you this formula. So any questions on this problem?
You'll give us formula for K, right? That one.
Yeah, if I wrote it on the
All of our
So any questions on this problem? No. Everyone signed in? For 12, it's just knowing the formula for the integral for arc length, and that's the integral of the magnitude of velocity.
It's like the easiest kind of thing ever. Like compare art with story. So it's not-
So that is it, unless you guys have any questions. Or let me write down them. If it is really 2 pages, I think these are the problems to study though. 10, 1, 2, 3, 9. And there's a chance that 8 could be on there. Or a version of 6. Like just one limit or something. But
Probably just gonna be one limit question. But we have to find like paths and all that.
actually 4 might be on there too. Yep. Did I forget 7?
Every problem here.
It's really every problem.
7 will definitely be on there. So
Okay.
some of these. 9 will be on there. 7 will be on there. Most definitely.
Yeah.
4 will be on there. 1 will be on there. 2 may not be on there. So this is just me randomly guessing though. But we keep going. So we have
Okay, so this is gonna be like an hour.
10,
Sounds like it's gonna be about an hour.
No.
Probably like an hour.
3,
No, it's fine.
9,
No,
7.
I'll just check it off the library. And
Yeah.
And maybe it's
Like this seems like a 50-page
then
problem.
I'll be there.
I think 12 might be on there too, but I don't know. It might be a simple like 3-point problem.
Like, yeah,
You could easily squeeze it in
they could
somewhere,
easily squeeze.
you know. But
but-
10 definitely, like that will take almost half of a test page.
Oh, is this the revised list?
Yeah, this is the revised list.
Oh, okay, let me erase everything I already wrote.
9, 10.
Me and myself.
Definitely study 9, 10, and 7.
Yeah.
Those are big problems. But then they could like combine 1 and 2 or do something like that.
Who knows?
I do think 4 would be out. Or they might do 4 next time.
It just gives us a 50-point test.
You have plenty of time though if it's 50 points.
Did they give you any like trick for domains?
For what?
Like the level curves and domains and stuff?
You should just make it 4 pages.
Like tricks for them?
Like trick, trigonometry?
Oh, trig.
We have one on the home.
I doubt it.
I think it's like the one where it's either the square root of it all or the 1 over square root.
But there's a homework problem where it finds the domain mathematically though. Like it simplified it somehow.
Oh, we ended up having a half test at the end.
Yeah, like in a viewing an example. What? That didn't. Yeah, I remember that being important. Like there was a problem on one of my exams where I had to use that.
They're like, well, you know, they have the whole room anyway.
But like
so it's like-
I sort of BS'd like because I didn't remember fully how to do it. But it turned out fine because you can like I don't remember. I just remember an example problem in the homework. Thanks. Most of them you can do by inspection though. It might like take a minute or two, but you want me to do that?
No, yeah, there you
I'll do this, Sheldon.
go. Now we show.